Today we're going to be talking about distributive property of multiplication. Distributive. Okay, when you think of the word distribute, you think of passing out, possibly. Well, when you pass something out or distribute papers, you're kind of, you have a group and you're kind of doling it out. You're passing it out, like when you distribute cards, when you're playing cards. Well, when we use the distributive property of multiplication, it states that one of the factors in a multiplication sentence can be broken up and then multiplied by the other factor separately. And those two products can be added together. So I know that's a lot. So let's look at an example and I'll show you how we can really play with numbers. Okay, so an example might be, let's say we're multiplying 4 times 9. Well, if we make a multiplication array for 4 times 9, we're going to go down 4 and we'll go across 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to illustrate how distributive property works. Okay, so do you agree that from here to here we have 4 rows, 4 groups, and we have 9 in each group? Let's recount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9. So this, we can say that this is 4 times 9, or 4 groups of 9. Well, we all know that 4 times 9 equals 36. 4 times 9 equals 36. Well, let's see how we can actually play with these numbers so that we can do this with larger numbers. The distributive property says that one of the factors, let's go ahead and take 9. I want to take the bigger one. Let's take 9 and break it up into an addition sentence. We can say 9 is the same as saying, let's break it apart right here. Isn't 9 the same as 5 plus 4? Yes. Well, have we changed this outside rectangle at all? No, we have not. We still have if we added all of these squares in this whole rectangle, we will still end up with the same amount of squares. We'll still come up with 36. So let's prove this. We know that 4 times 9 is 36, but if we break 9 into 2 parts, we say that it's 5 plus 4. We can say that 4 times 5 plus 4 times 4 will also give us 36. So let's see. In this part, let's cover this up. If we have this part of the rectangle showing, we know that this is 4 groups of 5. So we know that 4 times 5 equals 20, correct? So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, that's 20. From here, this whole part is 20. Okay, so then let's look at this other part. So that's part of our original rectangle. Now, in this part, we have 4 groups of 4. So we have 4 rows with 1, 2, 3, 4 in each row. So 4, 8, 12, 16. Let's write the multiplication there. It's 4 times 4 equals 16. Okay, I think we agree that 4 times 4 is 16. We have 16 in this area of our rectangle. Well, what the distributive property says is that one of the factors can be broken up and then multiplied by the other factor. So we broke it up. We're going to multiply each of these parts times 4, and then we'll add them back together. Those two products, these partial products, can be added back together. So let's add. We have 20 plus 16. So let's see if this worked. 20 plus 16 equals 36. So we can actually break things down into parts and we'll still have the same answer. Let's try another example. Let's look at some other numbers. Let's use the same example and we'll break it apart in a different manner. Okay, we have 4 times 9. So again, I'm going to draw a rectangle that shows or illustrates 4 times 9. There's down 4, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I still have 4. And I still have 9 in each group. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that still equals 36. 4 times, oh my goodness, 4 times 9 equals 36. Okay. Let's break it apart in a different way. How else can we get to 9? We could choose 6 plus 3 perhaps. So now I'm going to go across 3. 1, 2, 3, 4, 5, I'm going to go across 6. My goodness, I'm getting tongue-tied. I went across 6. This is 6. This is 3. Well, can we still say that this is 6 plus 3? Yes, we have in each row, we have 6 and 3. So we're going to multiply this factor times each of the parts that we broke 9 into. So here we could say 4 times 6 equals 24. And then on this side, we know that this is still part of our original rectangle. 4 times 3 equals 12. Well, distributive property says that we can break these apart, multiply by the other factor, and then add these two partial products together, and we'll still get the original rectangle. So we have 24 in this area, we have 12 in this area, but we see that it's still equal to 36. There are many ways you can break numbers apart. So let's try one more way, and I'll show you that no matter what you do, you can break apart 9 into different sets of add-ins, and you'll still come up with the same exact answer. Okay, so I'm going to quickly draw my rectangle. Maybe I won't get so tongue-tied this time. Okay, so we still have 4 down and 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this whole thing is 9. So let's think of another way. We've used 5 plus 4 and 6 plus 3. Maybe we could pick 2 and 7. So 9 can be restated as 2 plus 7. So I'm going to go over 2. I'll split it into 2. This is our new section. And then this is 7. Do we still have 9 across? Yes, 2 plus 7 is 9. So we still essentially have 4 groups of 9. So again, 4 times 9 equals 36, but we can break it down into smaller parts. So let's focus on this area right now. What multiplication can we solve to find how many squares are in this part of our rectangle? Well, it's 4 groups of 2. So we can say 4 times 2 equals 8. And then this section here, we have 4 groups of 7. So here's 4 groups, and there are 1, 2, 3, 4, 5, 6, 7 in each group. So 4 times 7 is the multiplication that solves this part of our rectangle, which is 28. So distributive property says that we can break up a factor and then multiply each part times the other factor. Add those partial products together and you'll get the original number. And this will really come in handy when we start doing 2-digit by 2-digit multiplication. So there is a reason we're doing this. Okay, so we have 8 in this part plus 28 squares in this area. Make sure to use place value when you add. 8 plus 8 is 16. And what do you know? It's still 36. That is distributive property. Okay, so now that we've practiced some distributive property and I've kind of showed you briefly what it looks like. Okay, first of all, you might be asking why we're doing this. Well, if you have harder problems, you can break them down into parts and you can help multiply mentally and you can help check your answers. And actually, I just think it's kind of fun, but it is something that we need to learn this year. And let's do a problem like, let's go bigger. Let's do 8 times 11. Well, most of us know that 8 times 11 equals what? You're right, it's 88. And I'm going to show you a picture of 8 times 11. But first, let's think of something. Let's look at the larger factor. Let's look at 11. what are two addends that come together to equal 11? So before we had 9 and we thought of like 5 plus 4, 6 plus 3, 2 plus 7. So now with 11, we could come up with something easy to multiply like 5. We know that 8 times 5 is easy to multiply. So let's break down 11 into two parts. Let's break it down into 5 plus 6. We know that 8 times 11 is 88, but we're saying that we can break 11 into two addends and multiply each of those addends by the other factor, put them back together, and then get the same answer, which is 88. Okay, so I'll show you at the model. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's close in our rectangle. Okay, so this side is 8. This side is 11. Well, I can break that apart. Instead of adding or counting all, what if we didn't know this multiplication fact? We could say, let's think of a strategy to figure it out. We don't have to draw it out eventually. We'll get to that. But if we did, golly, we'd be sitting there counting for days. We don't have to do that. We know that 8, let's break it into something that we do know. We know that 8 times 5 is something we can count. Okay, we can talk about multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40. So that's something we know we can do. We're good at counting 5s. So this part of the large array is 8 times 5, which is 40. So if I counted all these squares, we know that it'd be 40. Now in this section of the array, we still know that we have 8 groups, but what do we have 8 groups of? We have 8 groups of 6. 1, 2, 3, 4, 5, 6. So 8 times 6, we know that 8 times 5 is 40. So 8 times 6, or 6 times 8, is 48. So we're saying that we can add these two small areas, this area plus this area, and it should equal 88. Well, let's find out. We have 40 plus 48, and what do you know? It does equal 88. Now, could we have split this up in a different way? Absolutely. Let's try it, and then we'll work some on our own in class. Okay, so let's do 8 times 11 again. 1, 2, 3, 4, 5, 6, 7, 8. Let's go across 11. Let's double check our rectangle, make sure it's correct. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's think of another way to break up 11. 11 can be, gosh, we could do 10 plus 1. Why don't we do that? That's easy to do. I guess I should scoot this over just a little bit. Okay, so 10 here and 1 over here. Okay, so what is 8 times 10? We know that. It's 80. So if I counted all these squares, I don't have to do that. It's 8 times 10. It's 80. And what is 8 times 1? It's 8. Oh, look at that. 80 plus 8 equals 88. We still get the same answer. That's awesome. Okay, let's go smaller. Let's try, I just drew a random rectangle. Let's see what I came up with. 1, 2, 3, 4, 5. Let's do 5 times 1, 2, 3, 4, 5, 6, 7. 5 times 7. Let's just draw a random line. We know that 7 can be broken into 3 plus 4. Well, let's find out what's here. 5 times 3 is 15. And what would be here? 5 groups of 4. So 5 times 4 equals 20. We're saying that we can add these two partial products together and get our answer. So we have 15 plus 20 is 35. And what do you know? 5 times 7 is 35. That's distributive property. Good job.